Let's first draw a picture to understand this fencing problem. So we have a rectangular field like this, and the farmer wants to fence around all the sides, that is the length as well as the width. So he or she will be fencing around these sides, and the farmer also divides this rectangular field into two sections, something like this. And we know that the area of this rectangular field is given as area equals 37.5 million square feet. So I'm going to represent the million as multiplied by 10 power 6, because 1 million is equal to 10 power 6 units. So I'm representing this area as like this. Let's assume that the farmer divides as like this, or maybe the farmer can also divide it along any one of the sides, something like this also. The farmer can divide like this also. So if the farmer is dividing like this, then the side perpendicular to the dividing fence. So the line or the side perpendicular to this dividing fence is this side. So we can represent this as y, and the side which is parallel to the dividing fence is this side. So we represent this as x. So basically we have two sides, which is one of them is perpendicular and one of them is parallel to the dividing fence. So we can write down the equation for area. So area is basically the length and width of the rectangle multiplied together. This is equal to 37.5 times 10 power 6. So let's have it like this. Now we have to write an expression for f of x, where f represents the total length of the fencing. So since the farmer has to fence all the four sides as well as the dividing fence, so let's write an equation for f. So f is basically the perimeter of the rectangle, which is 2x plus 2y, and we should also add the dividing length, which is basically, which as you can see from the diagram, it is parallel to the side x. So this is basically equal to x. So this is the expression. Now we have to write down everything in terms of x. We still have y. So what we can do is, using this relation, we can determine y as 37.5 times 10 power 6 divided by x. So we can plug this into this expression and convert everything in terms of x. So let me do it over here. So therefore f, or f of x, is equal to, this is 2x plus x is 3x. So you can just add them and put it as 3x, and 2 times of y. Y is 37.5 times 10 power 6 divided by x. You should be very careful to put this unit, because it is one unit, that is the area is in million square feet, and the lengths are in just a square feet. So that is why we have to represent the million as 10 power 6. Now let's simplify this. This is equal to 3x plus, I can multiply this 37.5 with this 2, which is equal to 75. So therefore this becomes 75 times of 10 power 6 divided by x. So we finally got the expression for f of x. We will now find the derivative of this function, which is the expression for the fencing. So we have to find the derivative by differentiating both sides with respect to x. When I find the derivative on the left side, I get f prime of x, and derivative of 3x is just 3, because derivative of x is 1, so I get 3 over here. And then this 75 times 10 power 6 is a constant. I can just keep this as it is and differentiate only the 1 by x. Remember that differentiation of 1 by x, we can treat this as x power minus 1. So if you differentiate, you get minus 1 x power minus 2, and this is equal to minus 1 by x squared. So I can put this as minus 1 by multiplied by minus 1 by x squared. So therefore this is equal to 3 minus 75 times 10 power 6 divided by x squared. So this is the expression for the derivative of f of x, which is f prime of x. We will now apply the calculus first and second derivative test to determine the cost so that the cost of fencing will be minimum. So for that we need to find the critical numbers. Remember that critical number is obtained when the first derivative equals 0. So we have to set this up equal to 0, and this means 0 equals 3 minus 75 times 10 power 6 divided by x squared. And we need to solve x from this equation. So let's solve this. This is 3 equals 75 times 10 power 6 divided by x squared. I can multiply by x squared and then divide by 3. So then I will be getting x squared on the left side. So this is equal to 75 times 10 power 6 divided by 3. Now I have to take square root on both sides so that I get the value of x. So I take the square root. Notice that square root of x squared is x, and 75 by 3, we can simplify this. Inside the square root, this is 25. So we have 25 times of 10 power 6 under the square root. Notice that square root of 25 is 5, and square root of 10 power 6 is 10 power 3, because the power will get reduced by half if you take the square root. So this is equal to 5 into 1000. This is equal to 5000. So we can put the units as well. So therefore x equal to 5000 feet. We now confirm if this uh, length, that is this, if at this point of x the cost is minimum, we will verify using the second derivative. So we have to find the second derivative and then plug this value into this, and depending upon the result we can confirm if it is a point of maximum or minimum. So I'm going to first find the second derivative. So I'm using this first derivative. I am differentiating both sides. Differentiation of 3 is 0, so therefore this is 0, and we have a negative. So this is equal to minus 75 times of 10 power 6, and then I have to differentiate this 1 by x squared, which let me do it here. Differentiation of 1 by x squared, we can apply the power rule. First we convert into an exponent form like this, and when we apply the power rule we get minus 2x raised to the power of minus 3. So therefore this is equal to minus 2 by x cube. So which means I plug in minus 2 by x cube over here. As you can see that we have two negatives, so therefore this will become a positive quantity. So we get second derivative as f double prime of x equals positive times 75 times of 2 is 150 times of 10 power 6 divided by x cube. We don't need to actually calculate the complete value. Now we have to plug this x into this and determine if it is giving a positive or negative quantity. Remember that all these quantities are positive. 150 times of 10 power 6 is positive. And as plus if you plug in x equal to 5000 into this, the cube of this will also be a positive quantity. So we could see that f double prime of x is greater than 0. We don't need to exactly calculate. We just need to determine only the sign, whether it is greater than 0 or less than 0. So we found out that the second derivative is greater than 0, which means according to the calculus second derivative test, this is a point of minimum. So the x value that we have determined over here at this point or at this length, the cost of fencing is minimum. So we can take this as the final value of x, or in fact we can also call this as critical number. So therefore the critical number here is x equals 5000 feet. Now we have to determine the corresponding height. So let's use the relation for between the, it is the other side. So the other side is y. We can use this relation to find the other side, which is 37.5 times of 10 power 6 divided by x. So I'm going to use that and solve for y. So this is equal to 37.5 times 10 power 6, that is per million, divided by 5000. This I can write down as 5 times of 10 power 3. Now we can do the cancellations. This 10 power 3 will get cancelled with 10 power 6 as 10 power 3 times, and 37.5 divided by 5 is equal to 7.5. So therefore this is equal to 7.5 times of 10 power 3, which is equal to 7.5 multiplied with 1000, and this will give 7500. This is speed. So therefore we can finalize that the shorter side is compared with the x and y. X is the shortest, so we put 5000 feet as the shorter side, and the longer side is 7500 feet.